Hello and welcome to this presentation on the aerodynamics and wind energy track. My name is Alexander van Zuilen. I'm the track coordinator for the aerodynamics and wind energy track, and in this small presentation I will give you a little bit of an overview of the things that we do in our track. So first of all, what is the goal of our track? Suppose you want to come here to Delft and you want to study in the aerodynamics and wind energy track. We would like you to advance your knowledge of aerodynamics and wind energy, to strengthen your fundamental analysis skills, to develop your transferable skills, to increase your industrial experience, and to develop your ability to carry out an independent research. Now, these are a lot of goals that we would like to achieve, and the means that we have is to provide you specialist courses. Some of them are obligatory. We've selected them for you because you've chosen this track or later on a profile. And some courses, almost, let's say, 30 credits, you can choose to make your own personal choices in your study program. We provide an internship and finally a final thesis project, which also includes a literature study. Now, in this aerodynamics and wind energy track, we have two profiles, and they are different in nature. We have the aerodynamics profile, which is really focused on the discipline of aerodynamics. And that what we would like to do is to understand, model, predict and control aerodynamic flows. So we don't really look at one specific application, but we really look into the flow as a whole and we try to understand what's going on. We can do that by doing research experimentally, for which we also develop new experimental techniques. We can also investigate the flow through numerics, through CFD, for which we also develop new computational techniques. And maybe even using combinations of both numerical and experimental results, we can do new analytic techniques to understand the flow. If we understand what the flow is doing, we may even be able to design a new actuation system to control these aerodynamic flows. In the profile of wind energy, we look at the wind energy as the total system. And there we would like you to contribute to the global energy transition through innovative design, fundamental and applied research. So here we really focus on an application field and we need multiple disciplines in order to make, for instance, a new innovative design. So the different areas that we put focus on are, for instance, rotor aerodynamics, aeroacoustics, because it's at some point even more important than improving the performance of a turbine to make sure that it's also silent enough that you can actually are allowed to operate it. Wind turbine design, wind conditions, where do you place wind turbines, but also innovative wind energy systems like kite power and floating wind energy. So we have these two different profiles, and all these within these profiles we have different challenges in the field. As I already mentioned, in aerodynamics we look, for instance, at new measurement techniques. So using multiple cameras to make a tomographic, a 3D non-intrusive flow field measurement, but we cannot always get all the data from such a measurement. So we have maybe some empty gaps. We can also do simulations with very high levels of detail. And one of the questions that we have and try to answer is how to fuse both the data that we get from the experiments, but also the data that we get from the numerical modeling in order to get an improved representation of the flow by combining these two results. We also have, because with aerodynamics we have this focus on the aerodynamics itself and not one specific application area, we also have, for instance, research into much higher flow speeds. And this is an example of research that is related to the application of, for instance, scramjets, so it's more like a space topic. But in aerodynamics we will look into the boundary layer and see how the interaction between a shock wave and a boundary layer is in order to be able to control the flow or prevent flow separation, such that when applied in a, for instance, a scramjet, we can optimize the scramjet performance. In wind energy, there's many, let's say, things that need to be considered, because we look at the global energy system. So it's not about only just, for instance, designing a rotor, but also how to integrate it in the whole energy system and how to create new innovative systems such as kite power or floating wind turbines. Also, both groups work a lot with both experimental and numerical simulations. So also in the wind energy, you will have the application of the techniques that are also being developed within the track to do measurements in the wind tunnels on wind energy systems, but also compare them to numerical simulations that have been done on those systems. For these, we have a lot of facilities within the track. I'll just give a slide or a brief overview of, for instance, all the wind tunnels we have. These are all the low-speed wind tunnels going from a maximum speed of 35 meters per second to 120 meters per second. Each tunnel has its own specific operating environment. So the open jet facility is a bit larger. The low-speed turbulence tunnel is for real low turbulence. The A tunnel for acoustic measurements. And we also have wind tunnels ranging from transonic to supersonic and to even hypersonic flow velocity, so Mach 6 to 11, more for the space applications. As I said, we do both experimental and numerical work. So within Delft, there's a Delft Blue computing system, which students can also use with over 2,000 CPU cores. And for our department that we have, that we share with the Flow Physics and Technology department, we have a own cluster of over 3,000 cores that is also often used for master thesis projects. So career perspectives, suppose you're finished with your studies, where do people typically go? Well, there's, if you look at industry, 40% goes to an aerospace engineering related industry, 60% to other industries. So aerospace related, aircraft design, rocket engineering, satellite industry, airlines, airports. Other industries, of course, the wind energy industry is a large component, also in other sectors. And we have even consultancy management, and some people have a startup company. So I'd like to mention that you get a fundamental, let's say, piece of education. So also many students choose continue with a PhD position or move to other research institutes. So with that, I would like to conclude this small overview of the aerodynamics and wind energy track.